There's a moment in every scientific mystery where the noise stops sounding like noise, where the random becomes a rhythm, and the universe, for just a second, feels like it's trying to speak. For 3i Atlas, that moment came long before anyone was ready. When the object first entered the watch lists, observatories around the world began picking up soft brightness spikes, tiny flashes barely reaching the edge of our instruments. At first, no one cared. Brightness spikes are normal. They happen all the time. Ice breaks, dust moves, sunlight reflects. Simple things. But then, someone noticed something strange. A researcher in Chile, staring at a scrolling line of raw data, leaned back in his chair and whispered the words that would start a chain reaction. "This doesn't look random." At first glance, it was just static. White noise, a messy rise and fall of light. But then, buried deep inside the spikes, was a flicker, a soft, repeating beat, like a tiny heartbeat hiding inside the storm once seen. It couldn't be unseen. The next morning, teams from Hawaii, Spain, and South Africa began cross-checking the exact same timestamps. And that's when it became impossible to ignore, no matter where the telescope was, no matter what sky it looked through. The pulse appeared at the exact same second, a global sync, a single heartbeat, shared across the Earth. Slow, steady, too clean to be an accident, and too quiet to be natural. One scientist compared it to hearing a whisper inside a hurricane, a whisper that shouldn't exist, but somehow keeps repeating and repeating and repeating, as if waiting for someone to notice. And someone did. In a small control room in Italy, a graduate student ran the signal through a noise filter. She wasn't trying to prove anything. She just wanted a cleaner graph for her notes. But what came out of her computer made her entire team fall silent. Where the random static once lived, a perfect repeating shape appeared. A smooth rise, a sharp fall, a pause, then the same shape again, a pattern so steady, so exact. It looked like a metronome. A comet shouldn't do this. A rock shouldn't do this. Nothing drifting alone through deep space should do this. But 3i Atlas was doing it anyway. Every 6 minutes and 12 seconds, a pulse flashed through its light. Not brighter, not dimmer, just different. Different enough to stand out. Different enough to be noticed. And once it was noticed, the fear began. Teams launched emergency calls across astronomy networks. Charts, diagrams, raw light curves, all passed from screen to screen like pieces of a warning no one knew how to read. Yet, one group tried calling it an instrumental glitch. Another said it was just sunlight interference. Another blamed dust. But dust doesn't tick like a clock. Sunlight doesn't run on a schedule. And glitches don't show up on every telescope on Earth. So, the theories got stranger. Maybe the object was tumbling in a perfect rotation. Maybe ice was cracking at an exact interval. Maybe, somehow, it was reflecting sunlight like a spinning mirror. But those ideas failed too. The math didn't match. The energy didn't match. The shape didn't match. It wasn't reflecting light. It was sending it. A pulse. A beat. A signature. One researcher described it like this. If space had a lighthouse, this is what it would look like. Across the next 48 hours, observatories began feeding the data into deep analysis software. Not to decode the pulse, No one was ready to go that far, but simply to understand its behavior. What they found only made the mystery worse. The pulse wasn't just repeating, it was stable, perfectly stable. No drift, no decay, no chaos. Nature is messy, space is messy. But this was precise, like a message designed not to be ignored. And the strangest part was what came next. When the pulse was slowed down, stretched like a note held underwater, a small harmonic curve appeared beneath it. A second shape, quieter, deeper, almost like an echo. Most people in the room shrugged it off, but a few didn't, because the echo wasn't random either. It was spaced, measured, placed, as if the pulse wasn't alone. As if something inside 3i Atlas was making layers of light, stacked like chords in a song. But why? Why would a comet have layers? Why would it repeat them? And why now, so close to the sun? By the third night, the atmosphere in control rooms changed. Scientists who once joked through late shifts now sat in silence, watching the signal scroll past like a quiet warning. Something about the pattern felt intentional. Something about its steadiness felt aware. No one said the word artificial. Not yet. But the fear sat in the room anyway, because nothing this clean should exist in nature. Not without a cause, not without a purpose. And if it had a purpose, who or what created it? One astronomer described the feeling later. It was like watching a door open, very slowly, and realizing there might be someone standing on the other side. But then, something even stranger happened. When the pulse was converted into audio, a standard test used to detect frequency drift, the room filled with a soft, rhythmic clicking, slow, calm, almost hypnotic dot. But inside that clicking, there was a faint vibration, a trembling, a second beat hiding inside the first, like a voice trapped inside another voice. It didn't sound human. It didn't sound mechanical. It sounded ancient, like something that had been traveling for a long, long time, and was only now waking up. The lead engineer shut off the speakers, stared at the silent waveform, and asked the question no one wanted to say out loud. Is this thing doing this on purpose? No one answered, because no one could. By dawn, scientists had agreed on one conclusion. The pulse was real. The pattern was real. The timing was real. But the origin, the intent, the meaning, all unknown. All hidden behind that slow, steady heartbeat in the dark. And as 3IATLAS drifted closer to the sun, one thought began spreading quietly through the astronomy world. A thought no one wanted to believe. Maybe we're not observing it. Maybe it's observing us. What happens when the pulse changes? What happens when the static speaks again? We'll find out in the next chapter.